by the Pathologist, Proscia, and Lyco Biosystems. My name is Michael Schubert, editor of The Pathologist, and I'm very happy to be the moderator of today's online event, which will look at the whys and hows of adopting digital pathology. Please allow me to introduce today's speakers, Olga Colgan, Alexander Barros, and Nathan Bookbinder. Dr. Colgan has over a decade of experience in the digital pathology sector and is focused on how this technology can be leveraged to provide real benefits in both healthcare and research. Before joining Lyco Biosystems, she obtained a Bachelor of Science in Biotechnology and a PhD in Vascular Biology from Dublin City University in Ireland. Dr. Barros oversees precision medicine informatics and bioinformatics for the Sidney Kimmel Comprehensive Center, Oncology Tissue Services, and the Molecular Diagnostics Laboratory at the Johns Hopkins University. He leads the team at Johns Hopkins in combining clinical, computational, and molecular techniques centered on tissue specimens, with the ultimate goal of improving patient care. Nathan Bookbinder is a co-founder and the Vice President of Operations at Proscia. His background is in medical devices, biomedical engineering, and cancer research. Prior to his work with Proscia, Nathan was involved in the design, development, and validation of several medical devices, and received his MSc in Biomedical Innovation Development from the Georgia Institute of Technology. Today, these speakers will discuss the value of adopting digital pathology, share their experiences of how easy its implementation can be, including example applications, best practices, and important practical considerations for the transition, and explore the recent and upcoming changes that they anticipate digital pathology will bring to the laboratory space. The speakers will be on hand to answer any questions you may have at the end of the presentation, but please remember that you can submit questions at any time throughout the webinar. You will also see some polling questions appear during the webinar. Simply answer those questions on your screen to clear them, and the presentation will continue. So, without further ado, let me get today's webinar underway by passing you on to your first presenter. Dr. Colgan, over to you.
Thank you, Michael, for that very kind introduction. My name is Olga Colgan. I am the Director of Marketing for Pathology Imaging with Lyco Biosystems for EMEA, Europe, Middle East, and Africa. And I'd like to speak with you today about going digital and the whys and hows of adopting a digital pathology solution. So to have a little bit of a look back before we look forward, and to really have a look at the evolution of digital pathology, and it would be remiss of me not to maybe take a little bit of a step backwards and look at imaging in general. So really it was around the 1600s that we saw the emergence of microscopy, and then over the next 300 years really saw huge developments in the imaging, but staying predominantly with the same modality of a sample, a light source, and magnification, where your microscope, your sample, and your reviewer, in this case a pathologist, all have to be in the same place at the same time. Then around the kind of late 1900s, we start seeing the emergence of photomicrographs being used, giving some level of sharing to images. And then really in the 1980s, seeing the emergence of some kind of telepathology, so being able to remotely review slides in a live view type scenario. But it wasn't really until the turn of the century that we start seeing the emergence of whole slide imaging and really the birth of digital pathology. And in the last 18 years, we've really seen a technological maturity around digital pathology, both in the digital pathology specific solutions, both the hardware and the software, but also in the infrastructure and the technologies that underpin a digital pathology deployment. Things like the processor speeds and servers that would be used, the storage costs associated with housing a whole slide image, as well as the performance of broadband and increased connectivity and availability. And really this leads us to a situation where digital pathology today really incorporates all these elements of scanning and management and sharing and interpretation of pathology information in a digital environment. Then if we have a look at some of the trends that we're seeing in pathology as a whole, we see a decline in practicing pathologists. Really, at the moment, it's happening, but predicted to worsen in coming years, where we have a lot of pathologists reaching retirement age, and these are not being backfilled at the same rate or at the rate that we need globally to cover the pathologist requirement. And it's forecasted that there will be a net deficit of almost 6,000 pathologists worldwide by 2030. And if we add to this the increasing and ongoing demands on pathologists and pathology departments with the emergence of new subspecialties, and over 25 of them existing at the moment, and the emergence of things like new biomarkers and new detection methods, really we're faced with a situation where we're being asked to do a lot more with a lot less, and we need to look at innovative solutions to support that. Then if we look at pathology, and while some of these images are kind of quite extreme, it is reflective of a lot of pathology and anatomical pathology departments who are using glass slides, where you see you've got your paper files and your glass slides, and for large geographic regions, this can be a huge challenge, where you're faced with shipping slides around between different experts in order to read and share the slides, a shortage of pathologists, and then we see an increase in tests as well, they say, being driven by new biomarkers. And coupled with all of this, we have the innate fragile nature of glass slides, which really doesn't lend itself to packaging and shipping, both from the safety of the sample perspective, but then also from the time that it will take to ship those slides around. So here at Leica Biosystems, we look at the whole pathology workflow and take a holistic, really system-wide view of pathology, looking at from the excision of a biopsy and the piece of tissue right through to reading of that slide, and all of the steps in between, and look at a fully integrated approach on how do you enable control of the whole lab through integrated IT solutions, and managing the different steps throughout the whole process to ensure a standardization and quality throughout the whole process, and ultimately delivering a perfect glass slide which can then be digitized and reviewed. When we look then at the reasons to go digital, as I say, there are a lot of pressing kind of economic and social factors at play, but I think for people when they're choosing to go digital, it really is, well, what is the use case? What is the problem you're looking to solve? And where digital pathology can really support this is with things like being able to implement a fully digital solution where you can open up your laboratory information system and actually review slides, review your H&E, review your IHC slides from your LIS interface, and eliminate the need for glass handling at that point. And also to leverage rapid peer-to-peer collaboration to receive input from colleagues when reviewing slides. And again, to do that without having to physically ship the glass around between sites and between people. And where digital pathology can really come into play is removing that necessity where the slide, the microscope, and the reviewer all need to be in the one place at the one time. By leveraging digital pathology, you have that anytime, anywhere access to the slides by the right person at the right time. And it also helps not just for peer-to-peer collaboration, but also outside or external collaboration. So expanding your field of experts that you can call upon, and really looking at this and going, how do you make it as easy to use as possible? So I think there are a number of factors or steps when going digital in pathology or making that leap. And it can be quite transformational and impacts multiple departments within an organization. So looking at some practical steps on how to actually go digital, I think that the first big step is looking at finding your champion for digital pathology. Who is that person who really knows what they want to achieve and can help drive that message and get buy-in throughout the department? And then really looking at defining the needs of your organization and the goals that you're looking to cover, and set those out as ideally quantifiable steps that you're looking to cover. Then it's a case of looking at your individual needs, and every organization, every department is going to be different, and it's not a one-size-all approach or one-size-fits-all approach, where you really need to specify what are the type of samples you're looking at, what are the needs, what's the infrastructure that's required, and for things like integrating with an LIS, what does that look like and what are your requirements? Is that an upfront requirement? Is that something you add at a later date? Then it's a case of building the workflow. And when building the workflow, this is both looking at the physical side of things within the laboratory and the different steps that are maybe brought into the lab workflow, eliminating the need for some of the other physical steps. So things like automated case sorting that can be done leveraging barcodes, so that all the slides associated with one case are aggregated together automatically, which can help to eliminate the physical glass sorting and slide sorting that can be hugely time consuming within a lab. So to really build that workflow, as I say, both from the digital side of things as well as the physical laboratory impact. And then to roll out your configuration and your training on how, again, that system looks that's unique and tailored to your organization. Then absolutely it's about the rollout, the adoption, getting all your users up and running, and then looking at analyzing the benefits of that use case and going back to the defining the needs and goals. How does your solution actually support your initial premise and your goals that were identified? And then look to expand on that, and how do you grow the solution to leverage it most effectively and expand on the applications. So as mentioned, this really isn't a one-size-fits-all type scenario. When you're looking at adopting digital pathology, within Leica we consider three main areas to consider when looking at your solution, and break these into three categories of scan, manage, and analyze. So when you're looking at scanning, not all scanners are the same and not all needs of departments are the same. So it really is a case of considering what type of samples is it that you're looking to scan. Are they all bright field 1x3 H&E or IHC slides? Or do you do some fluorescence work? Potentially some larger slides for things like prostate samples, or with the emergence of a lot of new molecular biomarkers, are fish slides something that you would need to consider? and to look both at your current throughput requirements, the volume that you're looking to put through, as well as future-proofing to an extent for what will your needs look like within the next 1, 3, or 5 years. And then once you've defined what you need from a scanning perspective, that's fabulous. You can create whole slide images. But really then the key consideration is, how do you manage these? And it's about managing the images, but also managing the associated metadata that goes with these, integrating with the laboratory information management system so that you have automation of the transfer of information between the two systems, eliminating the need for double data entry, and also ensuring that you eliminate that potential step for error by having to enter data into a system. And really this system should be secure and robust, but also flexible enough to manage your different images, your different levels of users who may need access to the system, and as well as that, also your different deployment options depending on your IT department's preference, and whether you're looking at deploying for a single site, maybe on-premise, or looking at networking together a number of different sites in a hub and spoke type deployment, or alternatively leveraging cloud infrastructure and looking at potentially a hosted solution. So again, really tailoring the solution that's specific to the needs of your department. And then as we look at analyze being that third pillar to consider, it's about considering, well, are you going to interpret these manually, so on-screen analysis, but manual analysis where you can leverage things like the improved accuracy in doing measurements on screen as opposed to trying to do them under a microscope with a ruler and a marker, for things like measuring margins or tumor size. Or if you want to take it one step further and start moving towards the automated image analysis side of things, where really you start to bring in a level for biomarker interpretation, where you're bringing in a level of reproducibility and quantitative analysis that removes that inherent subjectivity that you have with manual review and really gives you objective, quantifiable data. So all of these things, as I say, are all to be considered when looking at a solution, but also to consider that you can start small and scale these things up to really provide the optimal solution for your department. With that, I'd like to thank you very much for your attention and pass you over to Dr. Alex Barris, who will continue from this point. Thank you very much.
Hi, this is Alex Barris. Thank you for the kind introduction. I wanted to speak to you all a little bit today about our experience in the research and educational landscape leveraging digital pathology. One point of clarification, just in case others were wondering, there really are two aspects when we talk about digital pathology. The first being whole slide imaging, in which we take a slide, whether it was stained with H&E or immunohistochemistry or other staining techniques, and construct a high-resolution image of the entire slide, and that is a static file that can be looked at over and over and over again. An alternative version of digital pathology is where we do live microscopy, in which a live feed is coming off of a microscope and is presented on different monitors, be they in the same office, in the same building, in the same state, or around the world. And the two have different strengths and weaknesses. Primarily, one of the biggest ones to consider have to do with the difference in the time it takes to generate the digital version of the slide, with obviously the live imaging from the microscope being nearly instantaneous, and whole slide imaging requiring some amount of time to prepare the digital version of the slide, distribute it into some framework, and then be able to analyze it. For us, the biggest use cases in the context of this presentation have been in education and research, along with the ability to generate high-quality publication-level images from our repositories, along with various use cases for telepathology and internal conferences at Johns Hopkins. Just as a brief overview of the hardware and software stack that one should be considering when implementing digital pathology, really it starts with obviously some type of hardware that's going to take the slide, or alternatively there are some technologies that are being considered that actually scan directly the tissue. Nonetheless, there's some hardware that has to take the physical material and convert it to a digital image. And so some of the criteria that you'll want to look at for conventional whole slide imaging modalities include how it handles the slides, what kind of optics it uses to visualize those slides, and what kind of detectors it has. And that set of the technology stack here basically is the hardware component. But there still is going to be some software that sits atop of that within the scanner to stitch together the different high-resolution patches that are taken of the image, and eventually compress the data into a manageable format and be able to represent the whole slide image in some of the more commonly used whole slide imaging formats. And then from that point, you'll want to consider what types of viewers and analytics you'll want to layer atop of that, starting with basic criteria like what your repository is going to look like. Is it going to be a network-attached storage device within your institution's infrastructure? Will you be looking for cloud storage? And then how will you visualize the slides? Will it be a local application on someone's computer? Will it be a web-based viewer? And what implications does it have for how well you can share and analyze your data? So this is just a brief overview of what the hardware and software technology stack looks like, and there are different factors that I think I reviewed there briefly of what you have to consider for each of these pieces. It's important to think about how the slides are generally, these whole slide imaging formats are generally stored in a manner that mimics the way we think about visualizing slides on a microscope, with different objectives representing different magnifications of the whole image. So our overarching goal is for the research education at Hopkins is to provide a simple web-based resource for viewing and annotating whole slides. We want to foster collaboration both within Hopkins' walls along with our collaborators around the world. We want to lay the framework down for a common infrastructure that will enable analytics on these slides, because that's the promise that digital pathology allows, is not just to visualize and interpret them by the same mechanisms we do on the microscope, but actually to enable analytics, image analysis routines, and the like to generate more data from these slides than we previously could. And also, we are proponents of open source algorithms in the context of these analyses. As an analogy, in my experience over the last couple decades in bioinformatics, I think that was probably one of the biggest pushes around 2000-ish to start opening up the algorithms that process bioinformatic data to the academic community so that they could really be refined and perfected, and that fueled a whole library of tools like Bioconductor in the R language, and I suspect similar things are occurring now in digital pathology and will continue to occur and will propel the field forward. Our research and educational web-based platform that I alluded to previously is available at the website you can see here, and I invite you all to come visit. You can log in as a guest. You can also register an account within our system so that there's some more capabilities that you'll be able to do. And our internal Hopkins staff also has a dedicated login where they can come in and upload slides. The ability to annotate cases starts with the concept of repositories. So in order to enable our researchers to do this, each repository within this framework has its own set of attributes that each project might be relevant to. So, for example, one repository is represented here by one of these tabs. For example, where it says pancreas in the slide that's being shown, may have certain attributes that relate to pancreas cases that are relevant. However, other repositories might be combinations of TMAs, like the one labeled TMA 833, and we may need to have different sets of attributes that we'll want to be able to annotate these slides with. As you can see here, we have a variety of different cases that are represented in these TMA formats, and that's a natural place where a lot of these analytics are being applied because it's a quick way to have a lot of different cases represented on the same slide and being stained with different markers. And these are active areas of research that various investigators at Hopkins are using actually the platform that you're seeing here to answer very interesting questions. We also have, for education, the well-known Johns Hopkins Surgical Pathology Unknowns Case Conference Series. This is an example of a public repository as opposed to what I was showing you previously, were internal repositories that can be shared with collaborators and the like. But this is one that you can access directly without having to log in. It represents a collection, I think, of nearly 2,000 cases. Each week at Hopkins, we collect maybe 5 to 10 interesting cases from the cases that were presented, that we saw, that were encountered that week. We annotate them with what the diagnosis is, and then the residents prepare their thoughts on them and to discuss it with attending each week, and you can see the attending's name and the date of the conference. And we have had this as a public conference for many, many years, but the ability to share it with the world the last few years has been very exciting for us. And when we go to our pathology meetings, I always am excited to hear that colleagues of mine find it very valuable to review these cases, both spanning residency level folks and attendings as well. While it does serve as an educational piece to be able to show these materials, in some sense, it might also be an interesting case collection from a research and analytic perspective, because these are relatively rare or more interesting diagnoses, and so if machine learning techniques would want to look at these and potentially try to develop some algorithms off of it, it would be an interesting substrate to look at. I mentioned briefly that we're very interested in having a framework for analytics, and this platform does enable that. We're working closely with our technology partners on this to enable effectively an API to access annotated slides for folks who want to dive a little bit deeper into these images and the data behind them. So in terms of what we're thinking about at Hopkins for various degrees of difficulty, if you will, in the analytics space, I think the most interesting and probably most applicable is to really refine our ability to do quantitation of immunohistochemistry. In particular, some of the more routine biomarkers. Again, even though I've had a significant experience in bioinformatics, which I guess most of the time people think about genomics, proteins are still molecules, so this is still molecular diagnostics, right? And is a critical piece of interpreting these tumors. So some of the common quantitative biomarkers that we look at today are listed there, including ER, PR, KI, HER2, and PD-L1, which has been a big important thing in the immuno-oncology space. So I consider these very low-hanging fruits because it's something that we should be able to do a good job with. There are already a lot of algorithms that are out there that have promising results, and we look to try and do large-scale validations to get these off the ground. Moving to more ripe fruits, I guess, are various deep learning approaches in imaging. This example here is a project that my team had worked on for the breast cancer challenge, the BAC challenge recently, that was, I think, closed out earlier this year, using deep convolutional neural networks to distinguish benign from malignant breast cancer. And I think these techniques really hold a lot of promise, in particular towards the notion of developing screening technologies, a concept that is definitely not foreign in pathology. There are a variety of things already in place in pathology that screen materials, both from a workflow perspective, humans screening slides for pathologists or machines. So I think that this holds a lot of promise to make pathologists very efficient. And then more exotic fruits that I think are coming down the pike in the next few years, such as there are various multiplex, multi-channel approaches, looking at both in the immunofluorescence along with conventional light microscopy approaches to multiplex or have multi-channels of biomarkers on the same slide, and that has a corollary to our ability to save precious biopsy tissues. If we can only have to use one 5-micron section for the 3 or 4 biomarkers that we need at the immunohistochemical level, it saves material for other analyses that have to be performed. And then some new fruits that I think are not yet ready, but we should be considering. And the concept is different techniques that have been published on recently, such as this example on pictographic microscopy, in which we move away from conventional bright field intensity-based imaging of these slides and consider other modalities that allow us to render a digital image, but with potentially more information than just what we can generate from bright field microscopy. So this kind of brings us into the regime of computational pathology, where we want to focus on, numerous quantitative needs are present in the molecular era, even if you're just talking about immunohistochemistry. There's definitely a lot of novelty in the single-cell parametric space, so the notion of being able to do something like flow cytometry, but in situ, which means that you're going to now have the ability to analyze both the parameters of the cell along with its location. And that's becoming an interesting concept in immuno-oncology as well, in the sense that what type of immune cells are present and where are they relative to the tumor cells. And then the thing I mentioned previously, which is the novelty in the way with which we digitally capture these slides, and how can we go beyond the conventional light microscope. So in summary, I think any informatics talk should try, if possible, to end with an acronym. So when considering your infrastructure needs, try to be savvy. Think about scanners, analytics, viewers, and informatics needs. And for research applications, we focused on our ability to help our residents with didactics, along with attendings throughout the world, be able to generate a framework that people can layer annotations atop of digital pathology, and an API for analytics, with a focus on, as I mentioned, open source for the actual algorithm development piece. Thank you all for your time, and we can hold questions, I think, till the end.
Thank you, Dr. Barris. I'm Nathan Bookbinder. I'm a co-founder and the vice president of operations at Proscia, a digital pathology, AI, and software company. And I'd like to do 3 things in the next 10 to 15 minutes. First, I'd like to provide a quick overview of who Proscia is and what we offer. Second, I'd hope to provide you with a fresh perspective on some of the common challenges and traditional barriers to going digital and how we've seen our customers overcome them. And then third, I'd like to talk about why I personally am so excited about the future of digital pathology and pathology in general, and that's computational pathology and AI. Proscia is a digital pathology, artificial intelligence, and software company. We know that pathology is going digital, and Proscia is taking it there. So we build products that enable pathologists to effortlessly transition from their traditional microscope workflow to the digital world through an industry-leading digital pathology software platform with modules for collaboration, image analysis, and artificial intelligence. And by bringing together that award-winning cloud and on-premises workflow software and pioneering work in artificial intelligence, Proscia provides a simple, flexible, modular, and future-proof software platform for pathology labs to go digital. So very briefly and at a high level, I'd like to quickly run through some of what our customers do on our platform. The first broad set of functionality relates to our data management and workflow management platforms. So we have 2 broad operating systems. The first is repository-oriented, and it enables you to store, manage, organize, and otherwise work with large collections of whole slide images and data. And then the second is a workflow-oriented operating system, which allows our users and our adopters to start with a case or with many cases and then move them through a customer-defined digital set of processes. The second set of use cases that we find our customers leveraging our platform for relates to collaboration, and whether that's through case assignment or real-time telepathology with large groups or in a smaller group setting for research, for interinstitutional reviews. All of that happens on that same base platform on cloud or on premises. And then broadly speaking, the third set of functionality and features pertains to digital IHC. PROSA offers a suite of research use only stain-specific algorithms that aid in producing consistent assessment of IHC and H&E stain slides. So, like I mentioned, PROSA is a software-only company, and we believe that while the digitization of these whole slide images in and of itself is, of course, necessary and useful, the real value comes in what software enables you to do with those whole slide images. So that was a 30,000-foot view of the company and our offerings. And if you have any questions about that, I'd be happy to address them in our Q&A portion or afterwards. I encourage you to reach out. Now I'd like to jump into some of the expectations, challenges, and considerations that you as a potential adopter or early adopter of digital pathology might have as you go digital. So when Olga started this presentation, she gave a great overview of the history of pathology and the evolution of digital pathology. But I'd like to focus on some of the big changes that have happened in the past couple of years. And there's really two big changes. The first is that computing technology, including cloud technologies, have advanced tremendously and really made their way into organizations. And this radical shift has enabled new advances in the technology, new advances in the use cases that are provided and in the user experience. And at the same time, these advances have driven down the cost of going digital. The second major shift is not really a shift so much as increased pressure, both on the one hand to drive revenue, to see more cases, to do more with those cases, and at the same time to reduce costs. But one thing that's remained constant throughout the entire digital pathology history is that you, as the customer and consumer and end user of digital pathology, are in the driving seat. So from my perspective, one thing that you should never concede on is that digital pathology systems must conform to your imagined and ideal workflow and not the other way around. So diving a bit deeper into that, your organization, your institution, your pathology group should be thinking about a wide range of requirements, and I'm sure that those are coming from your IT staff, from your legal department, from purchasing, from your pathologists and histotechnologists as well. And this wide range of requirements can broadly be summed up into three basic questions. First, does this work with what I'm already doing? Again, whether that's from a pathology, a management, or an IT perspective. The second question is, will this product serve me well today and tomorrow? Essentially, is this built to last? And then third, is this able to do everything that I want it to, everything that I need it to? And from our vantage point at PROSA, we see those as requirements concerning simplicity, flexibility, scalability, modularity, and then, of course, building a future-proof product. So, of course, adopting digital pathology can sound quite intimidating, and it really doesn't have to be that way. At PROSA, we focus on a few things to make going digital a bit simpler and easier and less intimidating. The first is by ensuring that we provide a flexible and scalable award-winning cloud and on-premise platform. Again, this is something that has to be secure, it has to be compliant, it has to be well managed with the right user permissions and user settings controls. But the flexibility ensures that it addresses the needs of your organization. The second thing that we do is provide use cases that can be added modularly and plug in directly into your existing platform as needed. So rarely is it a good idea to go digital 100%, so to go from zero to completely digital in one swoop. We find that that tends to cause a lot of frustration for everyone working at your institution and for the vendors themselves. And a modular adoption allows you to start small, start with use cases that you know are very real, very concrete, and could really benefit from digital, and then scale from there. And then the third thing that we do is we make sure that we take the complexity of implementation, training, and actually using the digital pathology system out of the hands of the pathologists. So if digital pathology is going to be adopted, it has to be usable by the pathologists and not just by technologists or technology-oriented individuals. For the last couple of minutes, what I'd like to do is talk about what really gets me excited about digital pathology, and that's computational pathology in digital pathology and artificial intelligence. Now, I'm sure that you've heard at least something in the past before this discussion about computational pathology and AI. And while I'm sure that there's 1,000 variations on the theme of what those two concepts mean, what it really boils down to is taking the powerful advances in technology and applying them in a way that enables pathologists in labs. So as a quick specific example, I'd like to point to some of the work that Proscia's R&D team recently announced concerning demystify. And what you see here is a visualization of an AI-powered algorithm that was trained to be able to identify tumor regions on a whole slide image. Now, while this remains a research use only technology that still is in development today, AI-powered technology like this, when plugged into a digital pathology operating system like Proscia's or others, and when applied appropriately to a workflow, has the potential to elevate the economics and science of laboratory medicine and ultimately put powerful technology in the hands of pathologists.